So let's briefly talk about how we talk about pH. Now, in very general, simplistic terms, we said a pH is, measures the acidity of a substance. And that's true. And, we said pH less than 7 is acid. pH equals 7 is neutral. pH greater than 7 is basic. Now, that's basically true from a, junior high school level. And it's not wrong, but we kind of need to be a lot sort of better at it. So pH actually means power of hydrogen and is defined to be negative log base 10 of your hydrogen ion concentration. You'll probably notice that it's the same as, every time you write the P, it's basically minus log base 10. So pH is minus log base 10 of H. pKa is minus log base 10 of Ka. pKb is minus log base 10 of Kb, and so on. So this, by the way, the thing is we kind of rely on the sort of self-ionization constant of water. So water can actually react with itself because water is amphiprotic. It can both accept and donate a proton. So this is going to donate an H+, and this will accept it, meaning that we will end up getting an H3O+, plus an OH-. So this is just what we were talking about before. So that this donates and becomes the OH-. So this is the conjugate base of H2O. This will accept it, and this is the conjugate Okay, so that means this double arrow, as you probably know, means that it's in equilibrium, and we can calculate an equilibrium constant for it, as based on what we did last week, and that's true. And importantly, this K called Kw is 10 to the power of negative 14. At 25 degrees Celsius. So just an extension note, Kw doesn't always equal 10 to the power of minus 14. As we mentioned before, K last week we said changes only with temperature, depending on if it's endothermic or exothermic. So in the case of this reaction, it is endothermic, which means that as K goes up, it's going to, as temperature goes up, the K is going to increase. All right. So you've got the self-ionization of water. It does this. Now, what's actually true is acid is that H+ concentration is greater than OH- concentration. That's really what that means. Now and a base is the other way around. You've got more OH- than H+. And what neutral really means is that H+ will equal OH-. So if you take a look at water, for example, this is 1 to 1 to 1 to 1, which means that when water self-ionizes, the ratio of H plus or H3O plus and OH minus will always be equal. If we consider this, these two always stay the same, the 1 to 1. So you're always going to, for every time this happens, you're always going to get 1 hydrogen and 1 OH minus. So therefore, and every time you go back, when it goes back, you're going to use up 1 and 1 as well. So as a result, the number of H3O plus must always equal the number of OH minus. Does that make sense? And so that means the concentration of H3O plus will always equal the concentration of OH minus, which therefore means that water is therefore neutral, has to be neutral. Now we said earlier K plus W is H3O plus times OH minus, and in the case of water, that's 10 to the negative 14. So because H3O plus times OH minus equals OH minus, what that means is this is equivalent to H3O plus all squared, because these two are equal, equals 10 to the negative 14, which means for water, H3O plus is 10 to the negative 7, which means minus log 10 of H3O plus, which is pH, is 7. And that's why the pH of water is 7. It might help you to just memorize a few of these things I'm going to write on the right. So pH is minus log base 10 of H plus, which is the same as negative log base 10 of H3O plus. pOH is negative log base 10 of OH minus. And because of water, pH plus pOH must equal 14. So that's the revision of your pH. And this is why, pH, this is what it is. So when you're really working out pH, it tells you the acidity or, how acidic or basic a substance is, but essentially, it is simply a number that represents, in sort of nicer numbers, the concentration. It relates the concentration of hydrogen ions. That's what it is. Okay, so the amount of concentration of hydrogen ions is affected. It's affected by the strength, because you could either have, it's like saying how many good troops do you have, or how many students did you have that passed. It depends on how many students actually took the test in the first place, because if lots of students took the test, then more of them will pass. And also how good they are. So if all the students are very good, and then they'll all pass. So that's the strength or the concentration. So both the strength and the concentration will affect the pH, right? Strength is strength, concentration is concentration, but they will both affect pH. I suppose it's a bit like saying, how tall is how tall you are, and how wide is how wide you are. Maybe use a square, for example. So, for a rectangle, you've got the length and the width. Now, length is length, left, right. Width is width. Width is width, up, down, shall we say. But they will both affect the area. Does that make sense? Hopefully that makes sense.